Hello and welcome to Richie's Robots. Today I'm going to show you how with a couple of cheap and inexpensive components we can have a climate controlled cheap heater and enable it to be controlled over the web via your phone or your computer or any device to turn it off and on, raise and lower the temperature, or keep it at a steady temperature. For instance, keeping your room at 20 degrees Celsius constantly. We're going to use a couple of cheap components, a smart switch, which you can get at most department stores for a couple of dollars. Usually you control them with a remote like this. This is one called click on, click out, but it will work with any switch that uses the 433 megahertz signal, which a lot of wireless devices use, such as garage doors and so forth. I'm going to use a couple of sensors with the ESP32. And of course, a cheap and inexpensive heater that you can pick up in any store. I think they cost about $20, $20. A couple of basic settings, hard, medium, just a fan or off. And then you can only kind of control the heating by guessing where this will go and then keep mucking around with it. We're going to do that all automated via this device here. So I'll now go to the whiteboard and explain exactly what we're going to use and how we're going to achieve this. Okay, so the devices we're going to use for this is going to be the power plug. It has a receiver built into it here, which receives signals on the 433 megahertz range, which is sent by, for instance, a remote. The reason it's 433 megahertz is it is an unlicensed frequency, which means anyone can make a device and run it on that frequency. As you can imagine, it's quite crowded, but it seems to be quite effective and has very good range. What it does is it just sends a basic code and it tells it to turn it off and on. We're then going to have the ESP32. That's going to be, of course, the brains of everything. And we're going to use that in conjunction with a temperature sensor, which is the BME280. And we're going to use a little sender for the 433 megahertz range. I'm going to use these three things in conjunction, and an OLED screen to display the temperature. We are first going to have to capture what code it uses, because it sends every signal in a code, and we need to find out, what this code is. So temporarily, we're going to use a little 433 megahertz receiver, a little thing like this, a little antenna. We're going to receive the code, we're going to look at the code, note it down, and then we're going to use it in this device here. And of course, we're going to have the heater, and we're going to make a simple web page in PHP and JavaScript. And we're going to run this web page on a Pi 3 of setup. Now, I'm not going to go into too much detail about the Pi and how I've set it up. There's another episode later on that will come up with that. But I will show you how we're going to do the page and how we're going to program this. Of course, all the code will be downloadable and links to all the parts and where you can get them from. And of course, I'll only be going lightly into this information. For much more detailed information, you can look at the links on this on this film, which is going to go and explain more in detail how all these technologies work. So the first step we want to do is get started with wiring up the receiver and getting the code that the remote sends out so that we can replicate this. So let's get on with it. Okay, so in order to get the code that's sent from this remote, we are only going to need two devices and some cables. We're going to have the ESP32 and we're going to have the 433 megahertz receiver. The 433 megahertz receiver will have a 5 volts of power, ground, and just a signal pin. So let's put it together. And as you see there, this is connected here to pin 5. There, sorry about that. Here is the 5 volt connection. Pin 5 just goes to any of these two. You can use any of these two here. Does not matter. And we have ground here, going to the ground port. As you can see on the back of the sensor, is clearly labeled which is for which. So now we'll get to the coding of it. Okay, so we now have the sketch open, which is going to show us the received code from my sender. Now, basically, this is just a sketch that I got from GitHub. The link is on the YouTube site, my YouTube page. And basically, from every signal, you're going to get this amount of information. You're going to get the code, which is like the ID of the signal, so that the device is only listening for that ID, kind of like a MAC address or like a postal address in a way. The period that the signal goes for, so it repeats it goes on and it sends that signal for 273 milliseconds. How many units of numbers there are? The IDs can get clopped up into units. So for instance, it could send blocks of these numbers, 8 different blocks. So, you know, it could send this plus another block of number, plus another block of number, plus another block of number. Just the way that the manufacturer set it up. And it's just telling the receiver there's only one unit because there's only one of these. If we, for instance, had it going like this, and yeah, a little bit different. Oops, sorry. So that would be 3 units. So that's what that means. Whether the group bit is on and off, so if it has a bit that you can set to on and off for that. The switch type, is it an on and off switch? Is it a dim switch? Or is it a dim switch when it switches on? So a dimmer, basically, a light that goes brighter and darker. And the dim level. So, you know, if you're increasing the brightness of a light with one of these remotes, you would say set the dim level to 3. And I believe that goes between 1 to 15. So first thing is we made sure the baud rate to communicate with the device is set at 115, 200. We're using ESP32, so it will be connecting to pin 5. Here it creates it, and it's going to basically show the code. And this, you know, run this function show code, and this is it here. And you'll see the address, period, group bit, unit, switch type, dim level, present if it's present or not, and a dim level. So to get the code, we will open up the serial window monitor, and I will I'll show you this straight after this film. I will press the off button, and you see there it shows the code, which is this number here. And its unit is 1, and it's switching off. The switch type is 0 because I'm switching the light off. And if I switch the light on, or the smart switch, if I switch it on, see, 1 and a 0. So now that we've got the code, we will be copying this. Oops, sorry, a bit of a typo. And we will paste it there to use in our program. All right, so this is the external view of what I've just showed you. As you see, here is the remote. You're on and off. You have to get quite close to the antenna, which is that ring there on the left. And basically, you know, you just press it and it records it. And as you see, as I press it, it comes up. And now we've got the code recorded. Okay, so the components we are now going to use to make this will be the 433 megahertz transmitter. As you can see, this is where it transmits on this little sensor here. 3 pins, one for ground, one for power, which is 5 volts, and one for the signal to send the data over. We'll be using this device here, which is the, oops, sorry. A little bit small, but it is the BME, I'll turn around, 280 temperature sensor. It also does the pressure, and it can do altitude based on, of course, the pressure. And this one has a SCL and SDA, so it actually uses the clock and the data port on the ESP. And power is 5 volts, and the ground is just the ground. To display the temperature, we'll be using this OLED screen. It's 64 by 32, and it connects via the SDA and SCL ports on the ESP32, and the power is 3.3 volts, and of course it grounds. there. Because we're going to be using two devices for the clock and data on the ESP, and because it only has the ability to allow one pin to use the SCL port or the clock port, and another for the SDA port, the data port, which is actually for SDA port 21 and for SCL port 22, we will need this multiplexing device, which will allow up to 8 devices to use one single clock port and data port on the ESP32. So we'll be using this in order to be able to use both the temperature sensor and the screen on just one ESP32. All right, so here's the device that's created. As you can see, I've got the ESP32 here. I've connected the transmitter here, got the multiplex board here, and that the temperature sensor is going to port 3 or SC3 and SD3 on this, basically channels, and the screen is going to channel 0 here. And that's really it for the configuration. So now let's look at the code for it. Okay, so now we've got the code shown in the Arduino interface. Now, before you start, you'll need to include a couple of libraries for the sensors. Again, links to all this is in my description. So you open the library manager up, and the first one you want is the BMP280 library for the temperature sensor. Some time for that to come up. As you see, I've got that installed. You also need for the screen 2 libraries. The first is the controller for the actual screen itself. And that is this one here. That's the Acrobit SSD 1306 for the display. I actually said before the screen was 32 by 64 or 64 by 32. It's actually 128 by 64. Sorry about that, that's a mistake. And you also need the graphics library to basically help you draw out the graphics to that. And that's this one here, the Adafruit GFX library. The latest version is fine. Then you also need to download the remote library here, and you'll put that in. Arduino keeps the libraries in here under Documents, Arduino libraries, and you'll see here we have the new remote switch library, which has the 2 header files that we're including here. All right, so once you've done that, I've got my defines here, the height and width of the screen, an API. What I use, that's like a security method. When I communicate with my web pages for updating, I have also there the API, and they have to match. So that way no one can just use my web pages without knowing the API on my network. We've just got some information about where the pages are located, IP of the server, SSID and Wi-Fi password. A heat counter, I'll get into that later. A boolean to tell the ESP if the heat is on or off as it flips it, because the 433 sender, of course, doesn't record whether it's on or off. It's just sending that signal. Now, the web server, what I do is, because my devices are throughout the house and not always easy to connect to a computer for updating the code on them, I use a little thing from OTA. What is it? Update over the air. Over the air, that's right. And I can update it by going to the IP address of the device and choosing the bin file and then updating it via this. To make a bin file, you just use this function here, and it will make a bin file in the same directory as the code itself is in. So this is quite handy to update your devices over the Wi-Fi. Here is getting the screen ready. And here is getting object, and here is getting the temperatures ready. Here is just the code to make that web page you just saw for updating. It's basically from the OTA example that you can get under the examples here. And I've just adapted that for use somewhere here. That's what basic OTA. I've got a URL decode and encode function, because when you send data over the HTTP, for instance, a space needs to be represented correctly. I believe that's %2O. You can't just have space in the data, or it won't work. And things like that. Just make sure that it's encoded and decoded correctly. Here is where sometimes Arduino takes a little bit of time to react. So we're just waiting for it to catch up. There we go. So here is connecting to the Wi-Fi. And a lot of this code is just displaying out to the screen what it's doing. And then I update the database, which is a Pi I have going with PHP on there and Apache. Then I'm just updating the IP address so I can access, look it up and see how I can access it. This is a check reconnect. I use this function throughout the when I need to do important things over the internet to make sure it is connected to Wi-Fi, because if it loses the Wi-Fi connection for whatever reason, it's not going to automatically reconnect. So for instance here, when I go to get a config value, such as what I want the room temperature to be at, I first make sure it's connected to Wi-Fi. And if it's not, it will just connect again. Then this is a function just to get data from, it's a get request. I have a PHP page that handles this. I'll show that later. And this gets data from the database. And here it sets data, for instance, what the current temperature is, and sets that so the database, the web page can pick that up. Here's that little I2C switcher I showed you about with the 8 ports that allows it to, 8 channels that allows 8 devices to connect to the clock and the data on the clock for the ESP32, because you only get one. You get pins 22 and 21 for that. They're the only pins that can use it, and this just allows you to switch and multiple devices. And in my circumstance, I need it for both the screen and for the temperature sensor. Here I'm setting up the remote to send the 433 signal. As you remember, we got the code, we recorded it. So I'll put the code there. The 4 here is basically how many times to press it. I press it 4 times to make sure it gets sent correctly. Usually when you press these buttons, you hold it, and it's kind of repeating. So it's going to repeat it 4 times. As you remember, the time it sends the signal out is for 272 milliseconds. Then we go into the setup. We begin the serial connection. We begin the wire connection. We switch and we start setting up the screen. We switch back. We set up the temperature device. If we can't, we switch back and put on the screen that there's an error. We switch back again. We set up the temperature settings. So make sure it has all the default settings, which are just used from the data sheet. Switch back, connect to Wi-Fi. Here is all the information just for getting ready for the server and connecting to the Wi-Fi and having the server get ready to start. That's the update server I showed you before. And then we're in the loop. First thing we want to do is check if we need to do anything with the server here, if there's any firmware that needs to be updated. If so, it'll go into that update process. Then we switch back, we read the temperature, we switch back and we display the temperature. And then what we do is we update and we just say what the current temperature is. We update the database. Then we see, is the temperature we want less than what the temperature is, higher than what the temperature is now. So say we want 20 degrees Celsius, but it's currently 19 and the whole system is enabled. Then we will say first update and say the heater is set to on, and then we set what the current temperature is. What we have to do here is a little bit of a cheat, because if we say, okay, we want the temperature to be 20 degrees, if it goes to 19.99 degrees, it's going to switch it on until it goes to 20 degrees, and it's going to switch it off. And that's going to happen very, very fast because, it's a tenth of a degree. And that's not good for a device that's drawing in 2000 watts. So what we do is I've got it to go to half a degree higher than what we want it at. That's quite reasonable. There's not such a difference that you're going to feel with half a degree. And then it allows it to slowly settle down to, it goes to 20.5 and then it slowly settles down to 20 and then it starts again. What we do is, this is in a while loop, so it just keeps doing this and waiting until it gets to that temperature. We're doing it as double, of course, and the thing is, because we're storing and sending strings over the interface, the web, we need to have a little nice function called toDouble. It's really nice and Arduino, very easy to have it just convert it to a double so that we can compare it. Every 2 minutes, 120 seconds, because this whole process takes about a second, we will say, we will send a signal to make sure the heater is on. The reason is maybe it got switched off for some reason or it lost power. Whatever reason, we'll just make sure every 2 minutes it's on. So we just send a signal and we tell the ESP32 via the balloon that the heater is on. So we set the boolean to true. Then we set the status, we read the temperature, we go and we display the temperature, and then we wait a second and we do the whole thing again and we go through it. And we'll do that until the heater is half a degree above what we want. Once it is, then we go to here. Once it is, it'll exit this while loop and it'll go back to the if loop. If the temperature is bigger, of course it won't be. So it'll go here, or if it's false, so it'll say, is the temperature now higher than what we want it to be? Or is it, do we want the whole system off? If so, update the status, tell it we're going to set it to off, serial print that for debugging. If the heater is on, then send an off signal to it, set the balloon to false, and then update the temperature. And then come to reset the heat counter, and then delay by 1 second. And that's it. That's all the code actually does to get the system working. I've tried to keep it as short as possible with the code and only make it as effective as possible. Okay, so now what we're looking at is the web pages that are used in conjunction with the ESP in order to do its communication. The web pages serve from a Pi 3 that I've set up, and basically there are only 3 pages that I need to use. There's a config page that has all my database connection. That's standard PHP connection information that creates the connection to the database. Then we have the API key here. I've removed it, but you have your own unique one that would match up with the one that the ESP32 is using in the source code that I showed you before. And some variables. We come through and we say, make sure it's a GET request. We get the API from the GET request. We match them, and if they match, we continue on. If they don't, we tell it that it's the wrong API key provided. We select value from the ESP config table we saw before, where the value name equals the value name that was put in the GET request. So for instance, wanted office room temperature, and it would return what that temperature is. We always do a prepared statement. This stops any chance of having any kind of SQL injections being performed. So we prepare a statement and then we echo the results back, which the ESP will get. Now, and that's basically it. Now we have this other one which does the same thing, but for a web page that I'll show you in a second. The reason we have 2, because it kind of seems like why we got one with getting information from database and another one. When we do it from the ESP also gets a lot of the header information back and a lot of other data that we just don't want. I think I've got it somewhere here. No, I've closed it already, but it basically gives a lot of data that we don't want. So we have to kind of do this value name and then, kind of like a JSON thing and then the value, and then we can do a substring based on the value name. I'll show you here. Here, substring based on the value name, go to here and then get the value of the value length. Because here we're saying we see what the value length is, the length of the actual string value, which we pass in here. So kind of going to mess around with that to get through all the header information that's returned. When we do it from our web page, we don't get any of that. We just get the actual data. The browser filters out all that other information. But it's basically saying here we select the value, and here we get the value. Okay. So we set the value here. So if we do an update in this page here, and this is the actual page that controls it. So as you can see here, we've got the current status, the current temperature goal it'll show. We can set the goal, we can turn it on and off. It only uses, it's quite simple. It uses PHP at the start to get the data. And then basically it's using AX, jQuery AX, every second to update or set. So it's just running these loops every 1 second. You can see that. So it's just basically a set interval function that AX uses for this. And then we can update the temperature here when we update it. And this is just for the page itself. And here at the end, we either check if it's on and off, and we allow you to turn the system on or turn the system off. This is designed to run on a phone. We use the CSS style here, which makes it displayed best on a mobile device by working out what is the width and device width and then scaling it to that. Just makes it a lot easier to display it. And then to use the page, I will show you in a second by opening up. Hang on, let me go here and open up a browser here. I haven't got one already open. So we just go to the Pi, and then we call it Office Heatzilla PHP. Okay, here he is. As you can see, he's constantly updating. So yeah, it's basically what it's displaying on that screen is displaying here. It's at 21, remember? Yeah, so once it drops to 21, it will go again. It's on, but for instance, and you'll be able to hear the fan come on, I believe, if we go to 20, and I'll show this externally. If we go to 22 and set that, you can hear that the fans come on again. If we set it back to 21, fan goes off. And if we set it to 22, turn the fan on, and then set that off, it goes off. Okay, I do see I haven't done current status, so just give me 2 seconds and I'll quickly make that work. Okay, sorry about that. So as you see, now the status is there. I changed the name of a column and I didn't update it in the code. So just a quick oversight. So as you see, turn on. Now it gives the status there, heating the room up, and then if it reaches its goal, we'll drop that goal back to 21. It turns the heater off. Okay, so that's basically it in action, and that's how you see it working. So thank you for tuning into another episode of Richie's Robots. This concludes this episode. I hope you found it interesting and maybe handy. If you've built it yourself, I'd love to see if anyone builds this, how theirs turns out. If you can send any information to me if you ever do this project, that would be great. And if you'd like to see any other things or have any comments whatsoever, feel free to send me a message or put something in the comments on this film. I already had someone say I should clean up the office a bit, so as you can see, the office is a bit more cleaned up now. And I look forward to another episode with you guys. Take care. And be well.